So much for your EQ mounts tracking accurately, which I've said many times they don't, and they always fail. The whole point is the sun does not move at a constant 15 degrees across the sky per hour.
So that audio was from a video by Gary Wybenga, where he's trying to make the case against equatorial mounts based on how much the sun's heading changes for each hour of the day from his chosen location. His argument goes, if we don't see the sun move 15 degrees per hour every hour, then equatorial mounts, which are supposed to counteract the Earth's rotation, cannot work, and therefore the globe must be false. So before I explore this using some basic geometry, let's get a recap from Gary's video.
I started at 6:03 a.m. and then an hour later at 7:03, it's at 74.60. That was a change of 8.67 degrees. 8:03, and now the sun direction is 82.91 degrees, and that's a change of 8.31 degrees. Then we're going to go to 9:03, and that would be a change of 8.77 degrees. 10:03, and that's a change from the previous hour of 10.16 degrees. At 11:03, and that was a change of 13.97 degrees. Okay, we're at the 12:03, that's a change of 22.99 degrees. Well, now we're up to 1:03, huge jump, 39.29 degrees in 1 hour. And there's another big jump on this one. At 2:03, it moved from the previous hour 40.38 degrees. Those are the 2 hours, these last two with the big jumps. 3:03, 4:03 to 5:03. Okay, this is 6:03. Now at 7:03. Now this is my last recording of the day. It's a little bit before the actual sunset. It's 8:03. And it's a change of 8.61 from the previous hour. So anyhow, the whole point is the sun does not move at a constant 15 degrees across the sky per hour.
Gary used timeanddate.com to get his sun directions, and that's because it matches what we see in reality for any given location. So how did I manage to acquire similar results using some basic geometry? Well, I started off by creating this point for Fresno, California using these coordinates. Next, I added this orange circular path for the sun to seemingly follow above. And I've positioned this path to match the expected declination of the sun for solar noon. In reality, this path would be slowly creeping southwards, edging a tiny bit closer to the equator as the day progresses. But I'm not going to bother with such a small change for this project if I'm going to keep it basic. So next I positioned this point to match the Greenwich hour angle of the sun for 6:03 am, which is the first in a sequence of 15, all spaced exactly 15 degrees apart around the circle. So that makes this point 7:03, this 8:03, and so on. All I have to do now is to get GeoGebra to measure the sun's heading using a couple of vectors that are tangent to the sphere, one that points true north and the other in the direction of the sun.
And I timed how many seconds it would take, or how many minutes and seconds it would take to change 1 degree. It took 1 minute and 21 seconds to move 1 degree in the hour after solar noon. Then I did another one at, I started about 4:09, and it took, 5 minutes and 21 seconds to move 1 degree. So each degree in the sky is considerably longer in the afternoon than it was around the solar noon time.
For some reason, Gary's made the assumption that any observer in any location would somehow expect to see a 15-degree change in the sun's direction for every hour that passes. And unless you're standing at one of the poles, this is clearly not the case. For example, imagine standing near the equator around the time of the equinox. Every hour before solar noon, the sun's direction will be roughly 90 degrees east. Every hour after, it's going to be roughly 270 degrees west. So the sun, relative to the Earth, is moving at a constant rate, and you can see the confusion. If equatorial mounts are said to track the sun just by rotating a single axis at 15 degrees per hour, how is it that can work? And then you've got the sun's changing altitude to consider too. Well, luckily for us, I've built myself a basic EQ mount with a telescope attached. So this grey section is always aligned with vertical, and that represents the tripod or the base. We have this white section, which I'm calling the polar axis, and I've made it such that it will change its angle to the base to match the latitude. So it will be at right angles at the equator, or it will be straight up at the pole. Wherever we put it, it will always be polar aligned. This section is also allowed to rotate, and it will do so at 15 degrees per hour, effectively cancelling out the Earth's rotation. Fixed to it is this green vector, which is our telescope, and that will rotate along with the polar axis. We can also point the telescope to anywhere we want using this slider, and this will be set to the sun's declination, and that means as the sun appears to travel around the sky, the telescope should always have it in view. And we can tell it's always in view because all we in the position of the sun can see is the front of the telescope at all times. And of course, if we tilted the telescope, it's very obvious that it's no longer trained on the sun.
Now, I remember when all these guys, back when I first became a flat earther, they would say, guys like Wolfie, that an EQ mount proves the globe because it can track on a one-axis rotation from horizon to horizon. In fact, they said it can go all the way back around and still be on track. Well, we don't see that.
I've added this trace checkbox, and what this will do is it will place the sun over the prime meridian and then trace out any path the tip of the telescope makes as it follows the sun out in space. And what you should see is the telescope will make a full rotation in the same time as it takes the Earth to rotate, and you'll notice that the circle it's made is perpendicular to the Earth's rotational axis. Now, the fact that this works with real equipment in reality has to tell you something about the underlying geometry. It seems that once again the sky can tell us something about the shape of the Earth. So this is the script I wrote, and you can find a link to this in the description. Every time I use GeoGebra, I do it to test something out or to try and get a better understanding of how things work, and it seems I learn a little bit more each time I do, so I hope these videos are showing a gradual improvement. And I'd like to thank everyone who has subscribed so far. I didn't think I'd make it to 100, and now I'm not far off 1,000, so thanks very much for that. I really do appreciate the support. So yeah, leave me a thumbs up and a comment if you can. Thanks very much for watching, and I'll catch you later.
Huge jump.